In this video, we're going to discuss how to solve a system of linear equations with substitution. Remember that a system of equations is when you have two or more equations with two or more variables. So when would we use something called substitution to find the solution? So we have a couple different options here. When the equations are difficult to graph, um, also if you tried graphing and then the intersection is not obvious, for instance, if it's in between the corners, it's a decimal, something that's not easy to determine the ordered pair. And then we're ready to use a method called substitution when one variable in one equation is isolated or alone by itself. So let's look at an example like that. And while we're going through this example, we're going to go through these three steps. First of all, we're going to substitute the isolated variable into the other equation. The result is a new equation that only has one variable, so it'll be all x's or all y's in the examples we do today. Then we're going to solve that new equation for the first variable, and then we're going to substitute one more time. We'll take the answer and plug it back in to one of the original equations. So let's look and see what that looks like. So in this first equation, it tells us that y equals 3. This is the most basic substitution problem because we actually have our first answer. It's already here. So our goal is to get an ordered pair. Let's see if I can get my pen tool to work here. So our goal is to get an ordered pair. I already know that the value of y is 3. So I'm going to take this first chunk. Sometimes this might say 3x plus 5. Well, we're going to take this whole chunk, whatever this is, whether it's one number like this or a whole expression, we're going to plug it in for the value of y. We're going to take it and we're going to plug it in. And so you could work these problems out on paper. So we're going to get 4x plus 5 times 3 equals 33. And now we're going to complete the rest of step 1, which is to simplify, solve for x. So 4x plus 5 times 3 is 15. We can subtract 15 from both sides. Bring down our 4x, equal sign, 33 minus 15. 28. Well, it's actually going to be 18. So we got to borrow. And then 18 divided by 4, that does not go in evenly. Let's see here. I don't have a calculator with me, so we're going to do a little mental math. Or algebra by hand. So that would go in 4 times 2 left over, 4.5. Okay. So this would be an example if we tried to graph these two equations. They look like they'd be fine to graph, but where these two graphs would cross we wouldn't be able to tell for sure if that was 4.5. And so to check to make sure that you're doing these right, you can always take x, plug it in, take your y and plug it in, just type that into your calculator, hit enter, and you should get 33. So let's look at a little bit more complicated example where we don't know that value immediately. So again, our goal is to end up with an ordered pair at the end of the problem. So we take the first value where this variable is by itself. We know that x equals 2y. So we're going to take 2y, we're going to plug it in for the x this time. We need to plug it in for that value here. So when I do that, I'm going to have negative 5 times 2y minus 4y equals 28. If you plug it in the wrong spot, what's going to happen is you're going to have x's and y's when you rewrite this, and that's going to be your red flag. Be like, wait, we got to start over. Okay? So when you plug in on this first step, everything should be x's or everything should be y's like this. So let's simplify a little bit. Negative 5 times 2 is negative 10y, minus 5y equals 28. 10y and negative 5y, that's going to give us negative 15y, combining like terms there, equals 28. And so to finish this out, we would need to take 28 divided by negative 15. And if you don't have a calculator, right now would be a good time to get one to go through this math with me. Oh, I see my mistake. Okay, so immediately up here, this 5 should have been a 4. Now this is going to work out a little bit better. This 4 needs to be here and here. And now negative 10 and negative 4 is negative 14. Negative 4, 28 divided by negative 14 is negative 2. So we know the value of y is negative 2. So now when you get your first answer, you're going to notice that it's always easiest to plug it back in to the first equation that you used to substitute with. But you can plug this into either equation. But this x is already by itself, so it's going to be a quick and easy plug in. So I'm going to take this and plug it in for y right here. And so I'm going to get x equals 2 times negative 2. And now I know that x is negative 4. Let's look at example 3. Again, one of these equations for substitution, we're going to have a variable by itself, and that right here on example 3 is the y. So we have 2x minus 9. We need to plug that in for the y in this equation. Let's see if I can do a better job of rewriting this. 3x plus 2 times 2x minus 9 equals 10. Double check, got it all wrote down. So now it's all in terms of one variable. These are all x's. And we're going to distribute to solve this equation. So this is like a multi-step equation to solve. So I'm bringing down my 3x. 2 times 2 is 4. 2 times negative 9 is negative 18. And I still have my negative 10. Or excuse me, equals 10. Now I'm going to combine like terms. 3x and 4x. Combine together to give me 7x. Still have my negative 18 equals 10. I'm going to add 18 to the other side, so 7x now equals 28. Divide both sides by 7, and x equals 4. Again, we need to now, we have the 4, we need to find the value of y. So we're going to take this first answer, and we're going to plug it into the first equation that we use to substitute, because that's how we get a quick and easy value for y. Because y is by itself, I plug in the value of 4 in for x. I'm going to have 2 times 4 minus 9. Simplify this out. 2 times 4 is 8. 8 minus 9 is negative 1. To make sure that you got that right, you could come over here and say 4 times 3 is 12. Plus 2 times negative 1 is negative 2. 12 plus negative 2 would give us 10. So that's, again, you can take your ordered pair and plug it in. Make sure you get the right answer. Let's do a couple more examples here. On this problem here, x is by itself. So we know that this is the value that we're going to plug in for x over here. And so the first step is negative 4 times negative 3y minus 2 minus 5y equals 8. Distribute the negative 4 times both terms. Make sure you pay attention to signs. Negative 4 times negative 3 is a positive 12y. And negative 4 times negative 2 is a positive 8. And I still have my negative 5y and my 8 here. So combining like terms, 12y negative 5y is 7y. Positive 8 equals 8. So now in this problem, I would subtract 8 from both sides. Those are gone here. Now I have 7y equals 8 minus 8 is 0. Love this example because when I divide both sides by 7, my variables didn't cancel out. I have y is a value of 0. 0 divided by any number is 0. So again, I take that and I plug it back in to my first equation here. X is going to equal negative 3 times 0 minus 2. Negative 3 times 0 is 0. 0 minus 2 is negative 2. So let's check and see what that looks like as an ordered pair. Negative 2, comma, 0. And I'm going to make this comma not look so much like a 1. A little bit sloppy writing with my slate here. So checking this out here, we'd have negative 4 times negative 2, which would be a positive 8. Negative 5 times 0 is 0, so 8 would equal 8. So all these problems are very similar. We have one value that we're substituting in. There's just little things to pay attention, like on this problem we had to distribute. We've had to distribute on another problem. This one had negatives. Then you combine like terms. Lots of little things to pay attention to. So one more example here. I have y equals 3x plus 2. The value of y here, we're going to plug it in for y over here. Now sometimes when we plug in, we don't always have a number to distribute, and that's okay. It just takes less work out of the problem. So just use those good algebra skills we've been working on this year, and you'll be golden on that. So going through this again, taking the value of y, plugging it in, this is going to be x plus 2 times 3x plus 2 equals 11. So we're going to distribute 2 times 3 and 2 times 2. So we're left with x plus 6x plus 4 equals 11. Now x and 6x here combining like terms is 7x. And we have a positive 4 and 11. Subtract 4 from both sides. Now we have 7x equals 7. Divide both sides by 7. X equals 1. So again, we used this equation to substitute. Originally, that's the equation I'm going to plug back into because that's going to quickly and easily give me my value of y. So 3 times 1 plus 2. 3 times 1 is 3 plus 2. Y is the value of 5. Again, write my answer as an ordered pair. Plug this back in. 1 plus 2 times 5. 1 plus 10 is indeed 11. If you want to try one more problem on your own, here you go. I guess this is what I was talking about. You don't always have a number to distribute. We could just take a quick peek at this. X equals 2y minus 6. I could plug that in for x right here. So I don't really need parentheses when I plug it in because there's no number out front. So I'm simply already going to have 2y minus 6 plus the 6y equal to 24. So we're ready to combine like terms. If you want to hit pause, finish trying this problem out on your own, feel free. Hit play when you're ready. And here we go. Let's see how you did. 2 plus 6 is 8y. Bring down our negative 6 equals 24. Add 6 to both sides. 8y equals 30. And to finish that out, you would divide both sides plus divide both sides by 8. Trying to make sure I didn't make any mistakes here because that's giving me 3.75. Don't recall having any decimals when I was peeking through these examples. So plug that in for x. 2y minus 6. 2 and 6 combined to give us 8. Add it over. Well, let's see. So if I take that and I plug it in, 2 times 3.75 minus 6 is going to give me my value of x. So let's see here. 2 times 3.75 minus 6 gives me a value of 1.5. Let's see if that works. Is 1.5 plus 6 times 3.75? It does equal 24. So it's okay to get decimals, just we get a little bit leery when we do, but our final answer is 1.5 for a value of x and 3.75 times the value for y. And what I did there, ladies and gentlemen, when I was kind of talking to myself in that video, is I took this 1.5, plugged it in for x, took 3.75, plugged it in for y, and when I typed that in there, I got confirmed that this ordered pair is correct because I got a value of 24. So that concludes our examples for substitution. Please let me know if I can help you with any of these types of problems.